Hello friends. Today in this session we will see how by the use of network address translation or simply NAT uh, we can access internet. So for that setup I have taken two routers, in which one is the ISP router, internet service provider, and another is the customer router. So the customer router, uh, the interface, the gig 0/0/0 is connected to the local network or a private network, having a local network of 192.168.1.0 slash 24, and which is connected to the switch and then to the customer PC, having the IP address of 1.10, and another interface gig 0/0/1 is connected to the WAN site, directing toward the ISP router, and the network I have given is 117.119.81.0/29. So slash 29 will give us eight IP addresses. Then the WAN IP are given as 81.1, and at the ISP router side 81.6, and from the ISP router it is connected to the internet server, having the IP address of 117.201.118.5, and the network domain is 118.0/28. So it will give 16 IP addresses. So we will first configure the interfaces of the customer router. So gig 0/0/0 customer side, and 0/1 WAN side. So let's go to the customer router. IP address, it should be the gateway of the private network. So 192.168.1.1, then marks 255.255.255.0, no shutdown. At the for WAN site, IP address of the gateway of the WAN site is 117.119.81.1, 255.255.255. As this is slash 29, 29, 30, 31, 32, so it will give us 8 IP addresses. So 256 minus 8, 248. The no shutdown. Now we have configured for the customer router side. Now let's do the same for the ISP router. So gig 0/0 is connected to the WAN site, and the 0/1 is at the internet server. So we will proceed to the this ISP router first. ISP router, for that I am going toward this first. No, enable config day interface gig 0/0/0 IP address of 17.119.81.6 and 255.255.255.248. Now shut down and gig 0/1 address as 117.201.118.1 255.255.255. As this is /28, it will give us 16 addresses. So 258 minus 16, it will give us 240. And now shut down. So here our interfaces configuration is finished. Now let's try to also I will need a routing protocol between the ISP router and the customer router. I can also provide dynamic routing protocol, but for instance let's use the static IP routing. So let's go to customer router. IP route, destination IP address 117.201.118.0 255.255.255.240, and the next hop is 17.119.81.6. This next hop is nothing but the WAN IP of the ISP router. Now IP routing is finished. Now without NAT, without network address translation, let's network address translation. Let's try to ping from customer PC to the internet server, whether it is pinging or not. Customer PC. Ping 17.201.18.5. It is not pinging, right? 100% loss, not pinging. It is not pinging because the private network, the private IP address which is given to the customer PC, it can be used only to communicate within the network, within the devices, within the this private network only. So to connect to the outside world, we need to translate the private IP address into the public IP address. So for that purpose we will enable the NAT. So while configuring the NAT, we need to define which interfaces will be our inside and which interface will be the outside. As the interface gig 0/0/0 is connected to the private network, it will be our inside, and the interface gig 0/0/1, which is connected to the WAN side, it will be outside. So let's again go to the customer router. slash gig 0/0/0 IPNet inside jet gig 0/0/1 when side, so it is IPNet outside. Okay. After this, IP net inside source, and here IP net inside source. Here it is going to translate the our inside, means our private network IP addresses. It is going to be translated into the this public network IP address. For that, I have defined this IP net inside. After this, within the again the private network, some particular private network IP addresses will be there, like our customer PC having 1.10. So we have to define that IP address, because the packet is going to be originated from that location, so that will be our source. So when I will define source, we got two options, list or static. So list will be used while if I have multiple PCs, that so in that cases I will have multiple private IP addresses, so I can create some pool, and it will be filter out from the rest of the private IP addresses. So for that, I will create an access list in which only those pool of private IP addresses will be permitted to be translated into the NAT. So in that scenario, we will use access list. But here in this case, I have taken only one PC, so there is no need to take list. So instead, we will take static, and the IP, our private IP addresses of the PC, which is 192.168.1.10. Now again question mark, and it is asking the inside global IP addresses. It is the public IP addresses. Which public IP address it is which is going to be assigned to this particular private IP address. So I want the public IP address is 117.119.81. I got IP addresses from 81.2 to 81.5. So any within that I can use anything. So let's use 81.4. So from now on, 117.119.81.4 will replace this IP address, this private IP address, whenever you want to communicate with the this internet server. So finish. Jet. No. Now let's see. Now let's after this NAT is enabled. Now let's see our ping again from PC to the internet server. So let's go to the customer PC. So the same thing. First, it will take some time to initialize those root and the network address translation. So after NAT enable, it is pinging. So internet server will see only the public IP address which I have assigned, and not the private IP address. So this is a uh, demonstration how in our real life also, when we are accessing the internet, our private network, with our private network we can access the internet. So it need to be translated first into a public IP address. After that it will connect with the internet. So so thank you friends.